Okay, so we'll look at our cutting speed. You guys tell me how to set it up.
3.22 times 105 divided by the diameter of the spool.
So divided by 1.5, which is
267.4.
267.4, so we'll go with 267. Is anybody at all struggling with this calculation? Because in 1 hour, in the room next door, David has a quiz he's going to be giving to you. It will be a required quiz. It will be graded. When you do this quiz, you must at least have this much written down, showing the numbers going into the formula. And then, of course, have the correct answer. Okay? Okay, so our other purpose for today, since it's been a while since we had a unit test, and there's been a lot of kind of miscellaneous stuff in this unit to prep us for our trig, I want to do a review so we can get a unit test in tomorrow so that you guys can walk away to spring break and kind of have a clear mind and not worry about coming back to a test later. So one of the things we want to review is I want you to try this. Convert that into decimal degrees. So how do we do it? Put it in your calculator? Okay, if we were doing it manually, we would start with the seconds. We'd divide by 60, which would give us 0.7, right? 42 divided by 60 is 0.7. What are we going to do next?
Put it on 18.
Bring down the 18 minutes. That's now 18.7 minutes with the 37 degrees. We're going to divide that by 60, which will give us 0.31. 0.3167? 1167?
Yeah, 1167.
1167, okay? And then, of course, we just put the 37 on the front of that. So it's 37.31167 degrees. 66. Yep. Sounds good to me. Well, I'm pretty sure you can figure out what's coming next. Convert that into degrees, minutes, and seconds. So what do we do with it? Okay. So the 49 is just going to stay the degrees.
Right.
The 0.738 does what? Times 60. So 0.738 times 60 is 44.28.
44 down.
So we keep the 44 for minutes. 0.28 times 60.
16.8.
16.8. So 16.8 seconds. And remember, we said you can have up to 1 decimal point in your seconds. So 0.8 is okay. If you left it as 17 seconds, that's acceptable as well. I would take it either way on the test. How about that? So of course, the first thing you have to do is you got to set it up vertically. 27 and 39 make 66. Of course, there's a problem with that. It's going to be 1 minute. We'll leave the 6 seconds. Okay. Then what? So 1 and 13, 14. 66 again. Same thing. We're going to drop the 6, and 60 of them go into making a degree. 1 and 45 and 19 make 65 degrees. So 65, 6, 6. So let's do 52 degrees, 18 minutes, 39 seconds, minus 27 degrees, 38 minutes, 17 seconds. So 39 minus 17. 22. Do we need to modify anything there? No, we don't. 18 minus 38. That's an issue. We borrow from the 52. This is now 51 degrees, and this will be 78 because we borrowed 60 minutes. Subtract to get 40 minutes. 24 degrees. Perfect. At this point, let's pause. Is there anybody that has any issues with addition or subtraction and needs to see more examples? You're good? Well, then let's have some fun with one like this. Multiply that. Where do we start? Well, we're going to go right to left. 6 times 21 is 126. But now that is 2 full minutes. So we're left with 6 seconds. We take 120 to make 2 minutes. Now, does this become 40? Say no, it doesn't. We have to multiply first. 6 times 38 is... Isn't it 228? Somebody check me. 228. Plus 2 would be 230. Now, how many do we get out of that? We're taking out 60 minutes to make a degree. There'd be 3 of them. 3 times 60 is 180. So what's left? There are 50 minutes left. Now, 6 times 19... 114 plus 3 is 117. So the multiplication is a little bit trickier. Anybody need to see another example of that? Okay. Well then. I'm going to set it up this way. Normally it'd be written out with a divide afterwards, but I'm going to set it up this way because this is the way we're going to calculate it. Oh, I don't want to divide by 6. That'd be way too easy for you guys. Let's do that. So there we go. Divide that one. Okay. Where do we start? Division's the one operation that goes left to right. So 7 into 48, 6 times. I'm going to call that 6 degrees. Now we got to multiply back. 6 degrees times 7, 42 degrees. What's left? 6. Before we bring down the 42, what do we have to do? Change that 6 degrees into how many minutes? 6 times 60 is 360. Now we can bring down the 42 with the 360 to make 402 minutes. Divided by 7? A lot. 57. 57 times 7 is 399, right? So we've got 3 left over. So yeah, we got to turn that into 180 seconds. Bring down the 3. Now we have 210 seconds. Divided by 7 is 30 minutes, or 30 seconds. So 6 degrees, 57 minutes, 30 seconds. Good stuff? Okay. Find the complements of 78 degrees, 19 minutes, 51 seconds. So our starting point, complement, is that 180 or 90? 180, or no, complement is 90. Complement, you get complements when you are right. So a complement deals with a right angle, or 90 degrees. So you subtract, we get 11 degrees, 40 minutes, and 9 seconds. How many of you came up with that? Anybody need me to go through the calculation? Okay. Find the supplement of 17 degrees, 43 minutes, 15 seconds. So, of course, the supplement is 180. You blew the surprise there. This is now 162 degrees, 16 minutes, 45. How are we doing so far? Good. Let's change gears just a little bit.
Years,
Like that. We're going to call this one here 30 degrees. We're going to call this angle right here, I'll call it 130 degrees, be more realistic. And I'm going to call this one up here 50 degrees. So let's start out, let's find this angle right here. 100 and what?
150.
150, good, because those two add up to a straight line, 180. Of course, this one's 150 and this one is 30. From there, what else can we find? Are there any other angles that have to equal 30 is one of the things I'm asking. Where?
Underneath where the 130.
Right there and there? Okay, perfect. Because this is a transversal, and these are parallel lines, and it always makes it easier once you highlight them because now it sticks out. That these two have to be the same, and then of course this one's vertical from that one, so it has to be the same as well. It's just having all the extra lines in there, sometimes it makes it difficult to see. Is there anything else here that has to be 150 degrees?
Yes, right, no.
No, it's not. I mean, yeah, this whole thing would have to be 150. Which it doesn't hurt to label it because that does help us a little bit. How does that help us?
150 minus 130.
Yeah, we know that since this is 130, this has to be 130. So this better be 20, which means this one is 20. Does that help us with anything? Well, it kind of does. We know that this angle has to be 50, which means this angle has to be 50, which means this angle has to be 50, which means this angle has to be, I thought I was going to catch this thing 50 again. Where'd we get 80 from? Yeah, it's a straight line, so that has, those three have to add up to 180 this time. And now, of course, we know this angle is 50, and this one is 80. Now that we know that, do we know this angle? No, it's not 90. Can't be 90.
80.
It is 80. Why? Because we have 80 and 20 here. Be careful, that 50 isn't the angle on the triangle. Since it's a triangle, they have to add up to 180. So that is 80, making this one 80. This one 100, because it's 180 for a straight line. Of course, 100 there. How about this one? That goes all the way back up to here, doesn't it? These are my parallel lines. This is a transversal. Yeah, those two have to be the same. I have always found problems like this. The one little piece of advice I will give you. Down below, there will be questions saying, what is angle 3? And somewhere up here, there will be one that's labeled angle 3, and you have to find it. When I encounter problems like this, I always forget about this down here at first. And I do exactly what we just did here. Okay, if I have this angle, what does that tell me? This, this, and this, and I just keep going. It was not tough to fill in all those angles right there, was it? But if I had come down here and said, find angle 3, and the first one I was trying to find was this one, or that one's, or this one, or something like that, that would have been tough. Because now I've got to find all that other stuff to get to it anyway. So in most cases, it's best just to forget about what it is you're looking for and just fill in everything you can from what you're given. It works a lot easier that way. This one should be a pretty quick review. What's the length of side X? How do we find it? Okay, yeah, this is the typical A squared plus B squared equals C squared, right? What sides are going to be A and B? 8 and X. How do we know that those are? Because those are the legs, which are the shortest sides, but more importantly, those are always the two sides that form the right angle. They form the L. So yes, it is 8 squared plus X squared, or the other way around. There's really no set order for those two. Equals C squared, or 17 squared. C is always the hypotenuse, which is always the side that does not touch the right angle. Then from there, we go through the math. 8 squared is 64. Can't do anything with X squared. 17 squared, 289. And then you subtract the 64 so that X squared is 225. And then square root. Square root of 225 is 15. Or negative 15, but negative 15 doesn't make any sense in this answer. I label my angles here. A, B, and C. And I label my sides. 15 inches, 17 inches, and 9 inches. And I tell you that the angles here are 38 degrees, 79 degrees, and what's left over there? 63 degrees, I believe. Round that off. Which angle has to be which? Why does A have to be 38 degrees? It's across from the smallest side. It has to be the smallest angle. Why does C have to be 79? It's across from the largest side. Very good. And of course B is 63. Wonderful. What's that mean? This is an isosceles triangle. Great. If I tell you that this angle here is 70 degrees and this side here is 12 centimeters, and I also tell you that I'm going to cut this down here in such a way that this, bless you, that this gets split into two equal angles. There's now some information I want you to help me find. One is, what's this length here going to be? 6. How do we know? Well, because since this is isosceles, if it bisects this angle up here, it also is going to cut this other side in half. So it is 6 and 6. What about this angle right here? 90. Why? That makes 90 degrees, or what we call an altitude. Makes it, intersects the opposite side at 90 degrees. Can I find this angle? How much? 20. How do we get that? Okay. Yeah, there's two ways we could have found it. Once we know, I lost my pen there. Once we know that this is 90 degrees here, well, that's a right triangle, so 70 and 90, you have to have 20 more to get to 180. Or, if we wanted to, before we divided it up, we could have used the big triangle, and we could have said, okay, we have 70. This one had to also be 70. That's 140, so this big one is 40. Divide it in half to make 20. Beautiful. Oh, let's see. Since you guys struggled with this a little bit yesterday, we're going to play with it a little bit more today.
I quit.
You quit? Let's do what all do I want to throw on here? I don't want to totally blow you guys away. Let's just start with this. And let's say that I give you this angle out here is 80 degrees. And let's just stick with that for now. From that, we're also going to tell you that this is a right angle here. Can I find that angle right there? Okay, how?
At the diameter and the line tangent, they have to intercept a 90 degree.
Okay, we know this is 90. This is 90.
We have GDO there.
Okay.
So you have to take, you actually take those four sides.
Okay, there you're getting to it. This is a four-sided figure. What do we know about a four-sided figure, about the angles? 360 degrees. We have 90, 90, and 80. Oops. We subtract those off, and we're left with 100 degrees, right? So this whole thing would be 100. How do we know that this is half? Yeah, this is a right angle out here. And, of course, since those two sides are both radii, they're equal, which makes this an isosceles triangle, which means since that forms a right angle, it's an altitude, cuts the angle in half. See how all these little rules stack up together? So from there, what else can we find? Let's say I want to find the measurement of this arc.
Well, that's actually 80.
80. Where'd you get the 80 from?
100. That was 100 degrees for the line.
Okay.
And ultimately line was get added.
Yeah, if this is 50 here, and if this is 50 here, this is 50. This is a diameter, which means this whole half circle is 180 degrees. So 50 and 50 is 100. That makes 80 left over for there. Do we know what this one would have to be?
130.
130. Where'd you get that from?
Just subtract it.
Okay, perfect. If this angle's 50, this one's 50, which makes this arc 50. And once again, this is a half circle, so 180. So subtract 50 from 180 gives us 130. I think that's about all the significant features of that one. Let's do some more. That's my goal. Like I told you guys last semester, if you walk out of here still feeling good about yourself, I haven't done my job well.
Well, I haven't felt good about myself since the past term.
Okay. Let's say that this arc right here is, well, let's do this. Oh, you're quick. I'm going to say that this arc right here is a 150 degree arc. This angle in here is 25 degrees. I want to find this arc right here. I'm going to give you guys a couple minutes to try this one on your own. So, what can we find? The first thing we can find really quickly is this arc here is 30. Because if this is a diameter, this has to be 180 out here. So minus the 150 is 30. How does that help us find this one?
It helps us find the other.
It helps us find this one. Very good. How does it help us find that one?
Double the other one.
If I call that, no, it does not necessarily double.
That's what I was.
Remember, this angle out here is half of the difference between the two arcs. So 25 degrees is equal to x minus 30 over 2. The difference between the two arcs. This arc minus this arc divided by 2. Recall that from before?
The 20. What?
Here. Let's just step back for a second. If we were going about this differently, let's say we were told that this arc is 40 degrees and this arc is 110 degrees.
Then I would just subtract.
Yeah, we would find this angle, we would subtract 110 minus 40 divided by 2. which is 70, divided by 2 is 35 degrees. So this will be 35 degrees. We got the same situation up here.
Why do we divide by 2?
Yeah, that's just life, darn it. Just kidding. If this is out here, if this is this inscribed angle here,
Yeah.
this angle is half of this arc, right? As we keep pulling in back smaller here, this angle gets smaller and smaller compared to how big this arc, or how big this arc gets. The bigger this arc gets, the smaller this is. But we still preserve the dividing by 2 because of this inscribed angle. Does that make sense? Technically, this angle here was this arc minus 0 because there was no arc here, and then divided by 2.
So in other words, it's just a rule.
It's just part of the rule.
All right.
Because you do, darn it.
All right.
Okay.
It'll work.
So back up here, it's this arc minus this arc divided by 2 to get this angle. The difference is this time we didn't know this arc. So we had to use a variable for it. So x minus 30 divided by 2 gives us that angle, which we already know is 25.
25.
We're going to times 2.
Subtract.
So 50 equals x minus 30. It's not subtract 30, it's going to be, yeah, it's subtracting 30 there, so we're going to add 30 to get rid of it. So 80 degrees equals x. So if this is an 80-degree arc, this is a 100-degree arc. What do you think? What's that?
I think it takes a big fish to fuck a whale.
Okay, that was not necessary, Jody. Let's see here. The other thing I want to make sure you guys understand is the bevel protractor, the vernier or the universal bevel protractor. Oh, let's see. Let's read this one for me. Where do we start reading the universal bevel protractor? At the 0 of the inner scale, the vernier scale, right? Where's that 0 at? It's between the 33 and the 34. So which one do we take? The smaller one always. So 33 degrees. And then we read the vernier scale. Which direction are we going to go? In the increasing main scale. So this is 30 and 40. We're going to read it going that way. Which one lines up? This one is 30, 35, 40. So 33 degrees, 40 minutes. Oops, I don't know how to put degrees there. 40 minutes. There we go. Now another skill. Let's see. If I tell you that this here is 80 degrees and 80 degrees, I'll tell you that's a right angle, that one's a right angle. Pretend that one looks like a right angle. Of course, that means this one has to be a right angle. What do I need there? This is 110 degrees. Help me find that angle. How do I do this? Well, how many angles do we have in this? 1, 2, 3, 4, 5, 6, 7 is correct. Well, what does that tell us? Okay, how do we use that to find out how many degrees we need? Nope. There's 7 angles. We take the number of angles or the number of sides. It should be 7 sides as well, right? And what do we do with it? There's 2 ways. You either take it times 180 and subtract 360, or the easier way was we subtract 2 from it to get 5. Then that number is times 180. and 900 degrees total. Remember, the formula is 180 degrees times n minus 2. Give you the angle sum of any figure, where n is either the number of sides or number of angles. They should be the same. So if we know this has to add up to 900, we have 90. We have 90. That's the one we're looking for. We have 110. We have 90. Do we have 80? $280. Where'd that come from? 360 minus the 80. And this one is 80. If we add those all up, what do we have? $740 degrees, I believe. You guys check me out. 740? Okay. So then what?
900 minus 740.
900 minus 740. Which is 160. Perfect. Not so bad? No? Okay. Well, it can get worse. You don't doubt it? So we're going to label those as right angles. Oh, let's see. Nope, can't do that. And let's call this one. I want you to find for me this dimension and that dimension. Of course, one of the tricks is always to find an overall dimension. In this direction, that's pretty easy to do. What is it?
3.7.
Yeah, we just got 0.8 and 2.9 is 3.7, period. So that's it. Find this dimension, subtract 2.0, which gives us 1.7. That one was easy enough. What if I asked you for this length across here, by the way? Could you have found it? How? You got it. This is 2.0, this is 0.45. So 2.0 squared plus 0.45 squared would have given us what? 2.05 inches. Perfect. But now, working the other way, getting an overall height here is a little more tricky to do. What's that?
No, overall height is 1.5 plus 0.45 plus 0.9.
Okay. 1.5, 0.45, 0.9. It's 2.4, 2.85, right?
You can just go 0.8 squared, well, 1.7 squared minus 0.8 squared.
Gotcha. If we think of this as a right triangle, we have one leg, we're missing the other. We can call this piece here, I call that y, or a, or b, or whatever you want to call it. You know that y squared plus 0.8 squared has to equal 1.7 squared. Y is going to come out to be, should be 1.5. That's why I kind of gave you a cryptic answer to that question. Because, yes, this point does line up with that point. But you can't assume that until you verify it mathematically.
Just go with 2.85 minus
1.25 there. Beautiful. Well, you guys ready for a test tomorrow?
That's all it's gonna be on.
Are you
That's
gonna
the
make
stuff.
sure that this is gonna be available online tonight?
I'll make sure I get this sucker processed and posted.
Will we see anything